All right. Okay, so we've got this carbon film. The current is flowing through here. So this, by the way, when we look at the resistivity formula, right, the resistance is resistivity times length divided by area. This area right here, this is going to be, if you can imagine that, that's our area, right? This will be our length, will be this distance here, right? And then they tell us that the resistivity is 4.1 times 10 to the minus sixth. Is that what? No, fifth. I could barely read yet. I need my reading glasses. Okay, which is actually pretty high. Most wires are like 10 to the minus eighth, so this has got a lot more resistance than that, right? So calculate the length of the film. Well, it's 82 is the answer for what R is, right? Okay. The length, we need the length, okay. And then the area is going to be 8 millimeters times 2 micrometers, right? So the area is going to be 8 times 10 to the minus third times 2 times 10 to the minus sixth, right? The resistivity is right here, if you can read it, okay? Plug that in there, right? And then you can get, we know the resistance, so you can solve for the length, right? I get that it's a few centimeters, like 3 or 4 centimeters, okay? So 0.03 or 0.04, something in that range, right, for the length of the film. Okay, the film must dissipate less than 1,500 watts, right, from each square meter of its surface to avoid damage. Calculate the maximum allowable current, right? By the way, what I did was I figured out the wattage, and then I forgot. I didn't get the second mark. I forgot to calculate the actual current. Okay, but let's just look at this, right? So 1,500 watts from each square meter. So you've now figured out the length of this, and we know the width of it, right? So the area, you need to figure out what your area is, and your area is going to be 8 times 10 to the minus third, right? Times the length that you figured out, right? Whatever that answer is from there, plug that in there. That thing that's 0.03 or 0.04, right? So now you know how much area you've got, right? Okay. Now the question is, how much power can we dissipate, right? So we're going to set up a proportion here, right? The power we can dissipate is to 1,500 watts, as that area that we got is to a square meter. Right? Now this area is going to be vanishingly small, right? So the power is going to end up being something like 0.3 or 0.4 watts of power, right? The power is going to be very small, right? So this, by the way, you know this area. You figured that area out. The only thing you don't know is the power, right? So I did that. I carefully calculated the power and got the right answer, right? But notice it says, what's the maximum allowable current? So the second step is, having found that power, use power is I squared R, right? We know that the resistance is 82, and you're going to plug that in, right? Yeah, and get what the current is. And then you'll get both marks. I was hasty, right? I thought, oh, they want us to calculate the area, but they want you to calculate the current. So statewide knowledge of quantities such as resistivity is useful to scientists. Well, you just use the resistivity to design a resistor. So do you think that might be a use of it? I don't know. I like that. I like that question. All right. And then this guy says, what if we instead of having the charge flow this way, we have it flow this way, right? Remember, the resistance is resistivity times length divided by area. So talk about, in both cases, the difference between this area and this area, right? Talk about the difference between that. That's going to cause something, right? Talk about this length here, which is something like for that length, I got 0.032 meters, right? Compare that to, indeed, 2 micrometers, right? There's a huge difference there. Resistivity doesn't change, but these both change by a lot, right? There's going to be an unambiguous change in resistance, right? So talk about that. It's going to change by a lot. Just argue through whatever is going to happen here, right? What happens if you make this super, super small and this a whole lot bigger than it was? What happens? Talk about that. All right. I think I'm out of here for this guy.